Alright, this video is part 1 of 5 of how to graph a piecewise function. In this first video, I'm just going to talk about what is a piecewise function and how to go from equation to graph. Now, the piecewise function at the bottom of the screen is actually what most piecewise functions will look like. F of x is equal to x plus 1 if x is greater than 1, but f of x will be equal to negative x minus 2 if x is less than or equal to 1. So it looks similar to what a full function would look like, only it almost looks like there's two functions going on. It will still be a function though, because our original graph, or our final graph, will still pass a vertical line test. Now in the upper left, let's try just a smaller piecewise function, or a function that's not going to use the entire graph. The basic idea of a piecewise function is that you're just graphing a normal function, such as f of x equals 3. F of x equals 3 is just like saying y equals 3, so we're just going to go up to 3 and then realize that that is a horizontal line. All of the points have outputs at y equals 3. However, a piecewise function has a limited domain, and that's what this is over here. This is what's called the constraint, or it's another name for the domain of each of these pieces of the function. So if we only want x values that are less than or equal to 2, what we're going to have to do is go back on our graph and say, well, if x is 2, starts right here on our graph, I don't want anything on my line that's going to be greater than 2. I only want all x values less than 2. So anything to the left side of 2 is good, but anything to the right side of that, so all of this out here, needs to be erased. And because I am okay with x being equal to 2, I'm going to start my line right there. So I'm going to do a solid dot at 2 and only have x values on my line that go to the left side of that point. We're only doing a piece of the line. Let's try that same idea over here at the right. F of x equals 2x minus 3. So normally we would go down to negative 3 and then have a slope of 2, up 2, right 1, for each of the other points. We'll make this easy to graph. Now before I draw my full line though, again I'm going to want to look at my constraint. For this one, on this graph, x needs to be greater than or equal to 0. Well, if x is 0 is the y-axis, and I only want numbers greater than or equal to 0, I don't want this point that I put to the left side. I'm going to get rid of that. I'm going to start my line where x equals 0. So right at this red dot here, and I'm only going to take points that have x values greater than 0, only to the right side of that y-axis. That's the basic idea of a piecewise function. We have a limited domain, or there's a constraint placed on our input values. So when we go down here, that's exactly what I'm going to do. I'm going to go ahead and put a block on the screen here. So give me 1 second, so that we can ignore part of our screen here. I'm going to ignore the whole second half of my piecewise function. I'm going to start off saying that f of x equals x plus 1, but only when x is greater than 1. So again, I'm going to go up to 1, place my point, and I'm going to say that I can go at a slope of 1, so up and to the right or down and to the left. But remember, I also need to pay attention to my constraint. I only want the points when x is greater than 1. So at x is 0, that doesn't work. Negative numbers won't work. And in fact, even at x equals 1, that's exactly where my line's going to start. So when x is 1, I need to start with an open circle. Then I can follow the rest of my points up and to the right and draw my line. Now let's do the second part of the piecewise function. So we'll ignore the top part, and from here x is less than or equal to 1. So again, at x is 1 right here, I'm only going to go to the left side. But I need to figure out where my line is. So negative 2 for a y-intercept, and a slope of negative 1. So again, down 1, right 1, takes me to exactly where x is 1. Now remember, I can't go to the right of that, but I can still continue to go up and to the left, up and to the left, up and to the left. So starting from when x equals 1, where my constraint tells me to begin, I'm going to go up and to the left to graph that line. And there is my piecewise function. Note again that it still passes a vertical line function, vertical line test, because even at 1, I would only run into the point down here at 1, -3. I would not actually run into my open circle, and anywhere to the right, I'm on the upper line, anywhere to the left, I'm on that lower line. Let's try one more piecewise function. And in fact, here we'll also try finding some of the values of our function. They may help us graph later on. So to find the value at g equals 0, again, the big idea is we need to check our constraint first. Does 0, x being 0, fall less than 2 or greater than 2? Since it falls into the category of being less than 2, I'm going to plug that in to that top function, 1/2 times 0 plus 4, and we get a value of 4. So I could plot the point 0, 4. 3, on the other hand, is greater than 2. So I'm going to plug that into the bottom function. -2 times 3 plus 9 makes -6 plus 9 is 3, and I could plot the point 3, 3. And the same thing goes for my last 2 points. -2 falls being less than 2, so 1/2 of -2 plus 4 is -1 plus 4 is 3. So I can go to -2, 3. And also 2 is greater than or equal to 2, so -2 times 2 plus 9 gives me a value of 5, and I can plot the point at 2, 5. Now, what I need to determine is which of these points fall on which of my lines. For the top function, remember we started at 4, but I'm traveling everywhere from 2 and to the left, anywhere that x was equal to 2 and left of x is less than 2. So out at x equals 2, which I had a value, if I plugged in 2 here, 2 times 1/2 is 1, plus 4 is 5, so I would be up here. Now notice I would have put an open circle, but there's already a solid circle there, and if you think about it, an open circle filled in by a solid circle, all you ever notice is solid. So think of it almost like paper, rock, scissors. Solid beats open circle every time. So we're going to leave this as a solid circle. But then I'm going to travel to the left using a slope of 1/2. So instead of going up 1, right 2, because I can't go to the right, I'm going to go down 1, left 2, down 1, left 2. And I'm going to follow these points out this direction. Then I'm going to go back and say, well, hey, x started at 2 here as well. When I plugged in 2 here, which is what we did on the bottom, we got a point at 2, 5. So 2, 5, there was my solid circle. Slope of 2 takes me down 2, right 1, down 2, right 1, down 2, right 1. And everywhere that x is greater than 2, everywhere to the right side is going to follow this line. I hope that helps you with piecewise functions. Good luck, and make sure you watch parts 2 through 5 to help you out with other various types of piecewise functions.